Hey baby birds, back at it again. This is the series in a parallel circuit, and you start it just the same way as the previous example I just did. Okay, so for step one, what is it? What is our first step? Go back and check. Oh yeah. Find the total resistance, right. Beautiful. And this time we're dealing with a parallel circuit overall, but within it, we have a series circuit. So that kind of makes it like a little bit easier in my opinion, because you can just add these puppies together and then solve for your parallel total resistance. So I have 62 plus 87, and the equivalent resistance here is 149 ohms. So then for our total resistance, we're going to do 1 over total resistance is equal to 1 over 64 ohms plus 1 over 149 ohms. Okay, I'm not going to put away my calculator because what comes next? That's right. I feel like Dora the Explorer. We are doing 149 times 64. And your common denominator is going to be 9,536. Okay, and since we're only dealing with two numbers here, the numerators are going to be the other thing's denominator. Okay, so 149 goes here and 64 goes here. And I know phrases like the other thing are not great in descriptive, words are hard, gang. Like, hey YouTube, like this video if words are hard, okay? And this is probably not going on YouTube, but whatever. I can dream. So then I add 149 plus 64. And my numerator is 213 divided by 9,000. Well, not divided by yet. We gotta flip those puppies. And we do 9,536 divided by 213. And for my total resistance, I'm getting 44.7, I'm rounding to 7 ohms. Okay, so then for step 2, I'm going to do what? Right. We're going to solve for our total current by doing voltage divided by total resistance. Okay, our voltage this time is 4.5 volts. And our total resistance is 44.77. This is probably looking like 1 over 11-ish. I do 4.5 divided by 44.77. And my current that I'm getting is 0.10, and I'm going to round to 1. Okay, and that is amps. Okay, and this time they want me to solve for the power across resistor 3. So resistor 3 is down at the bottom here. So I'm going to review what's going on like over here. Okay, so what we need to remember is that whenever you have a series portion of your circuit, your current is constant. But whenever you have parallel, your current is going to be different. We have more resistance in the bottom. Okay, so this part is what I'm talking about, the bottom of the parallel circuit. So that means that your current going across it is going to be less than the current going across the top. Okay, so we are going to need to calculate the current across those parts. And then we're also going, okay, so in a parallel circuit, your voltage is constant, but then in a series circuit, you're going to experience a voltage drop. So we have 4.5 volts going this way and 4.5 volts going this way. So knowing that, we can solve for, I'm just gonna kind of give us a little bit of practice with this first one. I have my 4.5 volts divided by 64 ohms. So I have 4.5 divided by 64. And my current across resistor 1 is 0.07, let's say 0.070 amps, okay? And we're anticipating that the current that's going across both resistors 2 and 3 is going to be less than that, because technically our equivalent resistance is 149, okay? So I'm actually going to use my equivalent resistance as my total resistance, because to calculate current for both of them, because remember, in a series circuit, so for the series portion of this circuit, your current is constant. I'm going to use that same 4.5 volts, but this time I'm going to divide by my equivalent resistance, 149. Okay. So 4.5 divided by 149. My current, which is going to be the same for both, is 0.030. Okay, and that does make sense because, like I said, more current wants to go across the path of least resistance, which is resistor 1. Okay, so we just solved for the current that we're going to use for resistor 3, but there is a voltage drop across those resistors. So we need to figure out how much voltage is lost at resistor 2, and then that is going to be the voltage that we use for, well, no, sorry. That subtracted from 4.5 is what we're going to use to calculate power with, okay? So to calculate the voltage drop across resistor 2, we're going to do our current times R2, which is 62. And so I'm going to do 0.03 times 62. And the voltage drop here is 1.87. Okay. So what I'm going to do to figure out my voltage for resistor 3 is I'm going to subtract, yeah, pretty sure. So I'm going to go ahead and subtract 4.5 minus 1.87. Okay, and that gives me 2.63 volts for resistor 3. Okay, my current is still 0.03. Power across resistor 3 is 0.03, which is your current, times 2.63 volts. Okay. I multiply, and I'm getting 0.079 watts. Now I pray that I do not shame myself and my family. Oh, thank God. Okay. It's always a moment of truth. We did it. It is 0.079 watts. Yay. It's good to be right. Jealous? That's okay. One day you can be. I'm just kidding. I just miss y'all so much. I miss our banter, and I hope that this helped you.